I have 20 minutes. That even fits me, to be honest, because I guess that my talk will be a little bit shorter than the previous one, at least, and definitely less connected to philosophy. What I would like to present is a very simple toy model of the online discussions, which is, in fact, kind of motivated by two things that I observed by our group in the cyberspace in the scope of Cyberemotions Project. But I would like to warn you that the model would be completely abstract one and would be much more connected to some toy models, physical toy models, than to the models that would reflect the actual state that's observed. At the end of my talk, it will be obvious why it's quite difficult to feed the model with the actual data. So to start with, I will tell about the stylized facts that are the foundations of this model. And the first one is the discussion evolution that's presented on the top plot. It often happens that when you have a discussion, it looks like a chain of comments. So, in fact, what you can see is when you go to some portal, some other medium, is that you see the posts that are organized in the chronological order, which means that most likely you would see the newest post as the first one. That's the one thing that is the foundation of the model. The second one is the thing observed in the data, which will be a key issue of the tomorrow's talk by Anna Chmiel, which is the emotional homophily. In short, I don't want to develop this subject as it's not mine. In short, you can tell it like this: that people tend to issue their comments with the emotional content similar to the previous one that was observed, and this leads to observations of such situations that you have clusters of messages of the same emotional sign. In this aspect, it is connected to some objective or negative or positive clusters. But as I said, I won't be developing this thought in large. But the main idea would be like this. So if people are so vulnerable to the previous messages, why don't we just assume that part of them would only look to the last post that they see, which would be, of course, a major simplification of this idea, but the models are simplified, and this is how we work. So that's written here. The general idea of the model is if we want to submit a post or a message, we take into account the previous ones. In this aspect, only the last one, which means the one that we see coming on the screen. And the other two parameters of the model that would sound nice for us would be something that we would call the temperature, in the sense that it would be the uncertainty of one's opinion or in this particular example, one's emotion, and the other parameter that could be given would be some kind of external field some global influence or affinity toward one emotion or something like that. How could it look like if you want some examples? Let's say like this: the external field would be the overall emotion of the medium. So let's say you have some media, some fora, some blogs that are really negative, and the other ones are really objective. Let's say some help desks or something like that, and the other one are just positive. So that would be the external feed. The temperature would be the uncertainty of one's emotions, in the sense that you just go inside to this forum, you read the last post, and you don't know, in the sense that you don't know if you want to express the same opinion or not. So the higher would be the temperature, the larger would be your fluctuations in this expressing this emotion. So the model is as simple as this. So we consider, for simplicity, we consider two states, the positive and the negative, which are here given by these green and red circles. And the model starts with the first node of the chain of these messages. So we start with the first node, which is filled with a random value, which means either positive or negative. And in each consecutive time step, you add another node to this system, and the new node's emotion, so the new node's variable, is dependent on the previous one. I will, in the next slide, I will explain in detail what is the dynamics of this taking on the previous emotion. And finally, we obtain a chain of a given size n, which means that after n steps, we just cut this dynamics. And to be precise about the dynamics of the system, let's define that a variable e that would be -1 or +1 for positive and -1 for negative, and we would write energy of the node that would have a form that's presented here in this equation, which means that the energy takes into account the energy for node I takes into account only the emotion of the previous node, the emotion of the node itself, which means the person that is arriving at the forum, and also the influence of the external field on one's emotion. And after the new node is added to the system, we calculate the energy difference in case if the value were flipped from -1 to 1 or from 1 to -1. That would be called a kind of emotional discomfort function. And then we follow, this is just a description of the implementation of this dynamics. So for people that are involved in models of statistical physics, that would automatically resemble the metropolis dynamics in the case of the Ising model. Of course, there are not two, but three large differences between the classical Ising model and the system that we are explaining here. That is that we do not have the fixed size, in the sense that this chain is evolving. The second thing is that we do not have the symmetry in this emotional discomfort function, which means that we take into account only the previous node, which is quite obvious, as we cannot take into account the next one, as we don't have it yet. And probably the most crucial thing is that we do not have thermalization in this system, which means that we change this energy, which means we change this variable only once. And we do not have a typical situation that's observed when simulating an Ising model on the chain. And these are the results of this dynamics. What you can see is the average emotion of the chain as the function of the temperature that is on the left. And on the right, you have the average emotion as the function of the external field. In the first case, you have it plotted for different values of the external field. And what can be immediately observed is that the average emotional value has a maximum for a specific value of the temperature in case the external field is smaller than 1. In case the external field is larger than 1, you do not observe such situation, which is, of course, quite different from the typical Ising model, where you do not observe this kind of situation for in the case if you have the ferromagnetic interactions. You can also observe how it looks like in the case of the dependence of the external field. You observe 3 plateaus for certain values of temperature, which is also unlike in the case of the typical Ising model. So you can write the analytical approach for this model, which is quite easy, in fact, as this model is nothing more than a Markov chain, to be honest. So you just have the transfer matrix that you have the probability P to go from state +1 to the state +1, and you have the probability Q to go from state -1 to state -1. And if you raise this transfer matrix to the nth power, you would have the probability that after n steps, you will still be in the state 1, or will be still in the state -1. And it looks like this. The analytical approach moves on, so you can calculate the average values of the emotion in the nth node, and you can calculate it for both situations, which means for the situation when you start from the positive emotion, and for the situation when you start with the negative emotion. And you can also calculate the average value of the emotion in the nth node. Here we have the comparison between the analytical and numerical simulations. You can go further and have the precise equations for this problem in the case of average emotion of the whole chain. And this slide shows that you have a good agreement with the numerical simulations, which is the same slide that was before. But in this moment, I just want to stress that the black lines are the solutions of this analytical approach. The most important thing probably in the case of this model is that you have a strong impact of the chain size on the results, which means that depending on the size of the system, the maximum for this temperature moves further closer to the value of 0. This is the first thing, that it's the value of this critical temperature is closer to 0. The second thing is that those maxima are higher for larger values of n, as you can observe in this plot. Of course, if you take the thermodynamic limit, the average emotion would follow the asymptotic behavior that's given in this by this equation by the equation above with the n equals to infinity. This can be followed by a simple assumption that you have the very small external field, and then it is possible to obtain the value for this critical temperature, and to observe that the critical temperature is given by this kind of function, where W is the Lambert function. And what's probably the most important in this case is that you have a very slow divergence with the critical temperature to 0, which is approximately as 1 over the logarithm of the size of the system. Okay, so I promised to tell you why this simple model, which gives complicated results, is rather hard to be validated in the case of real data. Because in fact, if you look at this, in the case if you extend this model for the free emotion case, which means the negative, the positive, and neutral emotions, you could calculate the respective probabilities, P, Q, and R, which are just the probabilities that you have the positive emotions after a positive emotion, negative emotions after the negative emotions, objective emotion after the objective emotion. And having done this, you could calculate the parameters T and H from those probabilities. So here you have the table that contains those values, those probabilities calculated in the case of several data sets that were taken in our consideration in the Cyberemotions project. But the point that prevents us from supplying that is that the calculation of P, Q, and R involves the a priori probabilities, which are unknown. Because if you go back to the beginning of this model, to the almost to the very first slide, you would see that we assume that the first emotion was issued by random, which means that in the case of only 2 emotions, it was 1/2. In this case, if we would consider free emotion state, that would be 1/3. And in fact, we do not know what is the a priori probability of issuing your emotion, because in fact, what you observe in this system, what you calculate, and what is in fact given here in this table, where you have the probabilities of issuing certain emotions in the three big data sets that we consider. These are the values that are calculated over all comments. They are accurate, of course, but they do not tell you anything about a priori thing that was really behind all this dynamics. So in this sense, it's rather impossible to validate this model with the data, which leads us to the conclusion that it's just only a toy model that could be compared with the classical Ising model as I did it in here. So, having said that, I would like to conclude it with this short summary. What I presented to you is a compact, exactly solvable model for reaction for the last post or last message. It takes for granted the structure that imitates the online discussion, which means the chain of comments. And the feature that's most interesting in case of this model is the characteristic temperature for which the average emotion is maximal. That would be quite nice to observe such a thing in the data, because it would mean that for a certain value of your uncertainty, the emotion that is let's say hidden in this external field would take over all this dynamics in the system, which means that if you have this uncertainty less or I mean smaller or bigger, you'll have the average value of emotions 0. But for this very case of the of your uncertainty, you would just copy the you would just copy the overall attitude of the whole medium. And what is probably also interesting for let's say toy physicists is that it shows an interesting interplay between the temperature and the external field, and also that it exhibits certain relations connected to the size of the system. So thank you. Sorry for that talk. I know that as the last one standing before the coffee break is rather hard.
Grateful. Still, we have some questions, I suppose. Would you be interested in making a tree instead of a line?
A tree in the sense imitating the...
Yeah, because some people attach to this trait and some people are attached to this trait, etc.
Yeah, I know that. That will be hard, of course, to achieve in this version. The idea why I follow this chronological order is that it is often that people have the possibility to change the view of this medium, and it's like a lot of them can use this chronological order. So I'm not saying in the sense that it's more natural way to have the tree than to have a chain of messages.
One thing that could make the comparison with real life difficult is the fact that very often the same people post multiple times.
Yes.
So one of the suggestions or ideas is to include a sort of internal field, the memory of what a certain person has posted before. This is, at least psychologically, very important, maybe as important as the post that is immediately above.
Yes, I agree. I mean, to be honest, if you seriously would like to compare it with the data, you would probably see that you have different values of H and T for different threads, to be honest, which means that one thread is hot and the other one is not. So probably it won't be so easy to have it really working.
What means gold
here? Yeah.
Yeah, actually, that is sort of related to that. It's easy when we look at these sequences of posts after the fact, but if you would be in there and you would see things coming in, psychologically it might be not the last message, but like a bin, a certain duration during which events come. So if it is a very active thread, then you might be influenced by the last 3 posts because they all came in the last minute. Whereas the one from last week, which is n-4, is less relevant. So instead of going post by post, having equidistant or whatever scaled time intervals and see what that would do.
Sure, that's an option.
More questions? Thank you very much.